All right. So what we're going to look at now is what probably is the gnarliest formula in the textbook. E there. And what these are, this is how to figure out what you're paying for each payment. So this is an APR payment formula. So if you take out a loan, this will tell you how much you need to make for each payment given the following. If you have R is your interest rate, and again, we'll turn this into a pure decimal. You'll be paying this over a number of years. Now, N in this case is not the number of times that the interest is compounded. This is the number of payments per year. So we're giving the letter N a new identity. It's the number of payments per year instead of the number of times compounded per year. A, well, we used to call A the amount at the very end, but we're going to call A, this is going to play the role of the principal. So unfortunately, we're not using the letter P, we're using the letter A. Hopefully that isn't too confusing. Now the trick here is we're going to do the following. We're going to calculate three numbers first. R over N, 1 plus R over N, and then finally negative in T. So here's R over N, here's 1 plus R over N. This exponent's negative in T. We're going to turn this into a number, get the number for this, get the number for this, then dive into this formula as it is. And hopefully this will make things a little easier. Well, hopefully. So for example, let's say you get a loan on a $70,000 car. And let's pay this at 9% interest for 10 years with monthly payments. So $70,000 loan, 9% interest for 10 years with monthly payments. So what that means are R is a pure decimal 0.09. We're doing this for 10 years. The number of payments, it's monthly. So there's 12 months in a year. So the number of payments per year will be 12. And we're borrowing 70,000. Now, first number we want to get, R over N, or 0.09 divided by 12. And here, let's get the trusty calculator. 0.09 divided by 12, and that's going to give 0.0075. Next, let's add 1 to that. So we've calculated 1 R over N. Let's just add 1.0075. And then lastly, negative NT. We're just going to take the negative sign and attach it to the product of 12 and 10, or negative 120. So these are the three numbers we're going to use in the formula. And hopefully this will make using that formula easier. but it's still going to take some steps. It's still going to be a little, it's still going to be complicated. So a monthly payment, again, that's A. On the bottom, 1 minus, in parentheses, 1 plus, bar over n to the minus nt. This is r over n. So now this becomes 70,000 times 1 minus, and here this is a parenthesis, not an r, that's another parenthesis. And we have 1 plus r over n, that's 1.0075. And then, so that's what we have here. Negative nt is minus 120, and r over n is going to be that. So hopefully this makes this a little easier to work with. Hopefully. So next up, let's apply this exponent to this number. So the way we can do that, take 1.0075. I'm going to give it the exponent, and just to be careful, I'm going to put everything in parentheses, 120, and then hit enter. And so that'll come out to 0.407937305. And I'm trying to use as many decimals as I can. I'll try to use as many as I can. So next, what I'm going to do, I'm going to do the subtraction. And again, that does get a little tedious. We'll hang in there. So what I'm going to do, I'm going to do 1 minus, and then second, and that gives me the previous answer. That'll give me a more accurate number, I think. So what that'll give is 0.0075 divided by, and again, I'm going to use as many digits as I can, though I'm actually trying to use the digits already stored in my calculator, because there's going to be more digits there than what I'm seeing on the screen of the calculator. And it's just giving me the number of digits that can fit on the screen. I'm going to keep just I'm basically using this number in each step. I'm kind of going step to step using the previous answer. So now this number is going to be the previous answer. So I need to now divide. Let me check something here. Okay, I'm going to divide this number by this. So on the calculator, now that this number is going to be considered the previous answer, 0.0075 divided by the previous number, and that's what I'm going to get. So again, one of the things that could throw your answers off is what's called round off errors. You do want to be aware of that. That is out there. So so that you don't run in the round off error, again, try to use as many digits as you can. So this will come out 0.012667577. And then lastly, we multiply those two times 70,000. And again, I'm using the previous number or answer times 70,000. And what it comes out to $886.73. Finally, at the very end, we get this as the answer. So I'm going to put that off to the side. So that's how much we're paying each month. All right. So another question they're going to ask you is this. What is the total paid out over the life of the loan? What is the total paid out over the life of the loan? So what we want to do is this. This total is going to equal the number of all payments times, well, our monthly payment. Now, if it was a daily payment, then we would multiply all payments times the daily payment. But since we're paying monthly, we're going to do that. So all the payments, how do we find this? How many payments are we actually making? Now, remember, we're paying this for 10 years. So what we want is we want years times payments per year. We're just finding this number first. This one we've already found. We know what our monthly payment is. We need this number. This number is going to be the number of years times the number of payments per year. And actually, let me rewrite this a little differently. This will be a little more familiar in just a moment. So payments per year times years. Well, we know that that's going to be N times T, or 10 times, oh, I'm sorry, let me back up, 12 times 10. 12 payments per year for 10 years, or 120. That's the number that needs to go here. So to find the total, 120 times, and we found it was $886.73. Again, I rounded this to the hundreds place. The answer from before, I rounded to the hundreds. And so what that's going to give, take the calculator here. So I rounded it to the hundreds place. So now I'm just going to go with the rounded number. I'm not going to use the exact number. This is what we're going to be paying. And lo and behold, here it is, $106,407.60. And that's going to be it. All right. So there's one last question they might ask. It's going to be this. How much interest is paid? And the way we do that, the way we find interest, it's going to be the total minus the principal. And I'm kind of being careful here. The formula we saw before was I equals A minus P, where this is the interest. This was the total, and P is the principal. Unfortunately, we're using the letter A now to represent the principal. So, okay, let's just not go with that. So in the previous sections, go with that formula, I equals A minus B. That's great for the previous sections. For this one, let's be a little more specific. The total paid minus the principal, or 106,407.60 minus $70,000 or 36,407.60. You're pay over $36,000 in interest. And that's it. So that's how you work with the APR payment function or formula. If you have any questions about that, let me know.